So ficonTEC is a privately owned company established in 2001 in the north of Germany. So our headquarters are located in Aachen, near Bremen, in north of Germany. And yeah, we have our sites operating in Germany, US, China, Estonia, Ireland, Thailand, Taiwan, and Malaysia. So we're quite a worldwide company with more than 300 people. And quite a big part of it is working in R&D, which are kind of the biggest contributors to what I will show here today, and keeping up with the let's say with the newest demands all the time. We're active in different industries and different applications, starting from high power laser diode to cameras, sensors, telecom, datacom, where AI falls into this case. Let's say LiDARs, biomedics. So wherever there is photonics, there is actually also a ficonTEC machine serving the market into automatic assembly and testing. We have more than 1,500 machines operating worldwide, and the number is growing quicker and quicker nowadays. And since 2010, we have an annual growth rate of 30 to 40%, which is more than the photonics industry itself as a whole industry. Now, starting with the topic, I've here summarized a couple of data which should make us reflect and actually should push us to work more and more into this direction. So, starting with the total capex that are being dedicated to the AI infrastructure, the number is roughly 500 billion in 2024, and this is growing much faster. This comes definitely with some power, with some energy consumption demand, which is expected to reach around 130 gigawatts by 2028. So what does this mean is that it doesn't only show an increasing trend in this field that we all of us know, and that's why we're gathered here today talking about this topic, but it actually shows that it's coming with challenges, not only in photonics, but in other fields as well, like in this case where we're talking about energy. So if we would attend, let's say, similar events in the energy-related topics, most probably we will see there that they are also dealing and discussing with similar, let's say, similar breakthrough changes to make this thing happen. But photonics is not only an enabling technology for this case, but it's also something that could release a bit of pain, because photonics is like could be actually the change that will be needed to make all the systems more energy efficient, most probably more cost efficient, but this not to just help the industry as a whole, but also to enable it to increase even faster, possibly, right? And here there is an estimation of annual growth rate that is expected in the global data center market, in the AI infrastructure, in the accelerator market, GPU, where NVIDIA, AMD, and so on are showing like growth rate, which is going tremendously fast, and also in edge data centers for low latency applications such as autonomous vehicles and so on. So practically, as a photonics industry, that we are considered as a key enabling technology for this industry. We should keep up with the same growth rate, and actually we're doing quite well. Now I will in this slide what I try to highlight here is actually photonics and AI. They are not anymore just technical niche topics. Now they're becoming everyday topics. So what you can see in common between the 6 articles that I selected is that, first of all, there is a tech giant in these titles like AMD, NVIDIA, TDK, and so on. You can see the word photonics mentioned almost in all of them. And you can see that they are mentioned in journals, newspapers, or magazines, which are known to the popular market, not just to tech-related people. So these are news from Reuters, from Financial Times, and from TechRadar, which actually are let's call them magazines or news portals dedicated to a broad audience, which means that photonics and AI is moving nowadays away from the technical niche that we're all common here to hear it for, and it's moving to the everyday use of every people actually, and that's a good news for all of us working in the industry. So my presentation will focus. So all the presentations before were focused quite in the technical breakthrough of photonics itself. As ficonTEC, we are focusing on automation, how to make these things possible, and how to make these things scalable to meet the high volume demands that are coming towards us. But what are the costs of any technology, actually? So here I've just broke down the total cost of ownership of adopting any technology. So we'll have some upfront development cost, some deployment costs, and then in the end, some operational costs to keep a certain technology up and running and possibly upgrading and following the market. We could work on reducing such costs by developing different partnerships, by having higher throughput, so higher volumes. Of course, the price per part will drop, by having a higher yield, so we have more efficiency in material usage, and by meeting industry standards. Certain industry standards are there exactly to meet certain quality, and also by making sure that our processes and our technology is scalable. And we believe that automation actually is key to all this and could help drive scalability from day one. So when we see cost versus time, of course, manual might seem more attractive because, of course, you might be able to do something in your lab with one person and a few tools. And then investing already from day one in automation might mean that you have to buy an expensive machine and probably like spend some time on it and so on. But over the time, this cost break even. So practically when you are at the prototyping level or maybe like product releases and so on, new product introduction, then maybe manual and automated costs will start to break even because then you want to be quick in pivoting, you want to be reliable, you want to be repeatable and so on. And there is already a break even here between manual and automated. Even though the volumes are not there yet, you could start feeling the pain in the manual work when you're trying to be traceable, repeatable, and so on. Still in the low volume but high mix product. And then it's clear when it comes to high volume, the automation will have much lower cost compared to manual because it's scalable. And then by scalable, I mean that you don't have to actually hire a new person every time you want to, let's say, add a certain amount of volume to your production line. With automation, you have the know-how. Now you're just extending only the hardware to do that. So having this in mind, ficonTEC is there to help customers starting with automation in mind already from lab systems. This is the machine types which we typically are serving the market, serving our universities, research partners, our let's say some startups, but also sometimes R&D labs within big players in the industry, right? So this is a machine which is made for prototyping, but with some production capability, but still in a semi-automatic way. You could use this to keep your IP internal, to make quick pivoting, to change your products fast, and to try things already to make them automated, proven from day one, right? So you don't want to develop something and then just discover later that you have to go back to the design or something like that just because it's not automatable. So this is to bring you into the topic of designing for automation. The second type of machines that we're offering is another, like increasing a little bit the level of automation. This is a closed door platform where you could already move into a batch production. It's made for production, for volume, but in the same time, there is some human interaction. You need an operator to prepare some trays to load them, unload them, and keep the machine running. In the same time, in this machine, you'll kind of have some possibility to repurpose the machine, to change your products. Maybe not every day, like in the first machine, or every week, but still every couple of months, every few months. This is a machine that will allow you some development capabilities. The third level of automation is when you have a machine that has to be run always by an operator, and then here you can practically have a loader and an unloader, automatic one, and then you just prepare trays and load and unload them. And this is a fully operated operator around machine. The next step of automation that we want to reach, and actually we have reached at several industries, is the high volume manufacturing inline business. This means that this means that practically you could load only raw materials in front, and then you would get fully assembled and tested packages on the other side. We have done this already in the automotive industry, where the standards are quite harsh. And we have done this for LiDARs, cameras, and sensors for the automotive industry quite successfully. And we're ready now to develop the same path for the AI demands. And from this point on, I will show you a few technologies that we have been working on lately. This is, let's say, starting from what, in terms of photonics, what is AI demanding from us? What are these optical engines? What do they require from the technical standpoint? Starting from a wafer level, of course, wafer testers have been around quite some time in photonics as well. But ficonTEC this year just recently launched a double-sided wafer tester for the COUPE technology, where the electric chips are from on one side and the photonic chips are on the other side. And practically, you could do simultaneous dual testing within the same machine, but in a machine which is actually compatible with automatic test equipment, ATEs, standard ATEs, which OSATs and foundries are already familiar in the semiconductor industry. So I will run this video very quickly. The video is described, and this shows how, like, a little bit of the architecture of this machine. So there is a wafer table where the wafer is loaded, and then there is a ATE compatibility that comes from the top. This is important also, very important also for the, let's say, high frequency small signal analysis when you want to do full characterization of the chip on the wafer level. And then from the bottom it comes the 6-axis engines with the photonics active alignment for optical probing. And the optical probing then can be both edge and grating couplers. This is like unique in the world. This technology is serving the double-sided wafer tester. Of course, the same techniques can be applied for single-sided, both electro-optical or only optical testers at the wafer and the die level. What else is needed is like here I put another video where we show another, let's say, the other part of the value chain that ficonTEC offers. So we do not offer only testing, but we offer the full, from testing until the full packaging. So here you also see a few steps, dedicated steps that will have the optical assembly and testing for photonics and for AI applications. So let me press run the video. So first, this is just free space alignment of lenses or micro lenses in front of photonic chips or in front of lasers. This is active alignment process. The second one is FAU attachment, and then you'll see also some fiber preparation. So let me, so this is some FAU attachment, and this is a fiber preparation solution. So it's laser stripping, and then you'll see some connectorizing afterwards. So what ficonTEC is aiming to do is to give a full value chain, and as I mentioned, in the automotive industry, we have achieved that by loading. So here's a fiber preparation, and so yeah. So what we achieved in the automotive industry by loading the raw materials, starting from the package, plastics, optics, sensors, electronics, all of the raw material up front, and then like having a package LiDAR every few seconds as an output, we want to achieve the same for the optical engines. What does this mean is that, yes, so far we can automate fiber butt coupling, we can automate free space alignment, we can automate wafer testing, but actually what we want to do is the connection between the cells, these machines, to be done in an automatic way. And for that reason, we want also to have this fiber preparation tool where you can put a spool of fiber, unspool it, strip it, cleave it, have prepared connectorization FAUs, connect them to another machine where you have where you can grip these FAUs and attach them to your chip, and so on and so forth. So like this, you can go uninterrupted for a long chain of processes within the same line. And here in the next video, I'll just show you how we've been building a photonic line. This has been at ficonTEC. We've been this is a relatively short line, I would say, for the automotive industry that we built, and we want to use this same experience actually in AI, and we are ready to do that. We have all the needed parts of the photonic value chain in that sense. So the line is being first manufactured at ficonTEC, and then tested there, and then taken at the customer side for another test before it's ready for high volume process. But we are not only enabling the AI technology with photonics, we want also to make use of AI. And here is just an example that I wanted to give. So practically, we want to improve, as a general scope, is to improve the OEE, the overall efficiency of equipment efficiency of our machines or power lines. And when it comes to high volume, this is very important. So you can improve it by reducing the downtime, by improving the performance, and by improving the quality of the products that are coming out, so the yield. And we have come up with machine learning algorithms which can act as like for preventive maintenance, but also for process optimization. What does it mean is that the machine will be equipped with sensors, with a separate PC, which will be monitoring all the data coming from the sensors, from the axis, from the vision, from all the tools of the machine. And while monitoring them continuously, the machine might automatically recognize, let's say, an axis is vibrating more than usual, or an axis is not being able to reach the certain speed that has been doing in the past, and so on. So like this, you can prevent a failure by already intervening, and the machine will slow down itself and will call for assistance. So we're using AI actually to increase the lifetime, but also, like as I said, the OEE of our machines. And this is very, very important when you talk about high volume manufacturing. And of course, we're using tools like digital twins and so on to go for let's say, as training tools and so on, so our customers can have full digital experience and full digital experience on our machines. This is what I call a horseshoe. So this will for you will receive the slides and you will get a big picture of what ficonTEC can do. I showed you a few videos. Those are just some few recent developments, but ficonTEC is able to offer you automated solutions starting from wafer testing and fabrication, from wafer testing and hybridization to die level testing, assembly, hybridization, combining different technologies, lens and FAU fiber attachments, but also fiber preparation, as you saw in the video, and also end-of-line testing. So practically, you will have all the assembly and testing cells that you will need for your final product. It's a German technology with some international footprint. We have strong R&D team, a big global service and support team, which is actually continuously growing because as our database of machine keeps growing, machine base keeps growing worldwide, also our service engineers, service and support team has to keep the same pace. We have already more than 1,500 machines delivered worldwide, and more than 400, or roughly 4,000 6-axis aligners delivered in the field, which is like a proprietary technology of ficonTEC for active accurate alignment. And all of these technologies are served by the same software. So one software serves them all, which means you can reduce the, let's say, the training efforts on your team when you adopt ficonTEC technology. We will help you, as mentioned before, starting from an MPI tool to develop the process together, have a test vehicle, go to a production tool, some training, and then be ready for high volume manufacture. And this way, together with ficonTEC, you could reduce the time to market when you're scaling up and when you have a plan for scale up in the near future. We have additionally, I would mention here, upgradability and future-proof technology, which means that, let's say, one example here shows a machine which is capable to start with 100 G up to 1.6 tera transceivers that has been in the market. So our technology is made to be future-proof, and we guarantee that by following a modular approach which makes your investment future-proof and lowers your total cost of ownership. Here I will summarize with a few takeaways, which, starting from the beginning, I wanted to highlight that photonics is a key enabling technology, which means it has to keep up with the technologies which is enabling, which in this case is the AI topic. So AI is having a tremendous demand, which means photonics has to keep up with this demand. Automation, we believe, is key to reduce costs, increase volumes, and meet quality standards. And early adoption of automation will help you also have an easier adoption and easier scale up. ficonTEC will help you and will offer you a value chain starting from wafer to die to module level, both for assembly and for test. And we are a strong partner starting from product development, MPI, up to high volume manufacturing. So with this slide, I will close, and please feel free to ask me any questions. So this is a map of our presence worldwide nowadays. Thank you very much.